So, sorry, I was a little bit late this morning. All right, welcome to the final lecture for MHIT 3. So we're just going to cover off the last few bits and pieces of physical design today. So on Tuesday we looked at what physical design means, the whole concept of bits and atoms and transitioning from one to the other. We looked at how we can go from atoms to bits with some polygon modeling, photogrammetry. Now I did actually look a bit more into detail at this, and turns out the reason I couldn't figure out why 123D Catch, or why the web app doesn't seem to be creating models anymore, is because apparently it just doesn't. So yeah, they've basically abandoned that, and their primary focus is on mobile. So you install the app on your mobile device, you scan it. There is still, much to my frustration, a Windows app that you can download, but there is nothing for Mac. So I recreated these from the Windows app yesterday. It's a bit annoying, to be honest, but yeah, there used to be a web app you could do everything on, so you could upload photos and stuff. They're now mainly focusing on mobile, so you capture the photos and then you do everything from your mobile device. There is still a Windows app. Now the thing about the Windows app is it's got features that either don't exist in the mobile app or I can't find in the mobile app, which allow you to do things. So we looked at this example of this camel, which was all screwed up and didn't come out very well. What you can actually do, the way this technology works is basically it finds corresponding points in all the images, and from that it can figure out where the camera was each time, or in each photo. And if you know where the camera is in each photo, you can calculate the 3D geometry by saying, okay, well, we know what the object looks from this direction, this direction, this direction. And what happened in this one when it failed is basically a whole bunch of the images it was not able to find these correspondences for. So what you can actually do is you can go in and manually say, okay, this point, you'd pick maybe a corner point or something. So you might say, the very corner of this orange square is here in this image, here in that image, here in that image, here in that image. You basically say where these points are, and with a minimum of 4 points in each image, it can figure out where the camera was in each frame. Doesn't seem like you can do that in the mobile apps. You can do it on the Windows app. You used to be able to do it in the web app. The web app doesn't exist anymore. There's no Mac OS app. So I don't know what they're doing, but it is still possible. With the mobile app, you have to capture the object on your device and then upload it, which wasn't ideal for me because I already had captured these images of the camel and the robot as JPEG, so I had to download and install the Windows app on my desktop machine and then run it on there. So it is still possible to do this stuff. And if you guys want, I can make these captures available so that you can download the Windows app onto your machine, have a play with them. Whoops, let's scroll up a little bit. So it was actually a combination of things. So I took more photos, I had more details, so I've got a couple of books, whereas the problem with the one book I had, especially because the camera was standing in the middle of it, a lot of the interesting details. So these correspondence points are points which need to be easily identifiable across all the images. So by putting the camera in the middle of it, often, a bunch of points weren't visible. I can see, if I have something staying like that, I can see all these details from this direction, but then if I turn the camera around like that, I can't see them anymore because the camera was blocking the way. So by putting them in the middle of the two books, there was always sort of a range of features available. And the boxes did help as well, particularly when I was taking photos from this sort of angle, because here, the books aren't particularly visible, but the boxes are. So the difference between this one and I did actually do 3 scans, which I showed you guys. So there was the one which turned out really bad, then there was another one which was good, and this one which is slightly better. It's actually not a huge amount of difference, and the only real difference between this one and the one which was sort of the middle, it didn't have these boxes around the outside, it just had the 2 books, but they actually worked out fairly similar. And then there's the robot one, which for some reason it hasn't it just hasn't finished processing yet. Cool. That's all right. I did start that yesterday afternoon, and then yesterday evening, and then I went home, and apparently it hasn't worked. So yeah, 123D Catch is easy when it works. But yeah, as I said, now it's only, they've ditched the web app, which is why I couldn't figure out. When you go on the website now, basically all you can do is upload photos, but you can't actually start the processing process, which doesn't make any sense to me. So it's primarily a mobile app. There is a Windows program. Capture images on the device and upload to server. Windows version allows you to upload JPEGs or whatever, so you can do pre-captured stuff. Models automatically generated. For the Windows version, you can manually specify point correspondence. So I mean, one thing which might be interesting to do, I can make the that bad camel example, whoops, this one here, available to you guys so I can put the photos up. And one thing you might want to have a try doing is basically downloading the Windows app, and then if you like load all those images and you'll see like there's, of the 8 images, 5 of them it can't actually detect where the camera was. So you could try manually selecting the points and seeing what sort of quality you can get out of that. You can actually get something quite good, but yeah, it just requires some manual intervention.
For the mobile app, how were you doing with the webcam?
So I took the photos I took were just with a digital camera, and then I uploaded them. Yeah. So yeah, 123D Catch workflow, shoot a loop of photographs, upload the serves. So I mean, this changed a while ago. It actually used to do it in the app, but now it does it on their server because it's part of the software as a service. And then you can tidy some of the stuff up in MeshMix, which we'll look at later. So we already talked about quite a few of these things, but I just wanted to sort of, now that I actually had the time to sit down and look and try and figure out what they've done, so once the model's been created, we can post-process it to remove any artifacts and fix any mistakes. This can be done in 123D Catch or almost any 3D modeling program. Autodesk also provides their own software specifically for cleaning models, which is called MeshMixer. So if we go back to the website, I should have brought a mouse through actually. So if we go here, you can see in apps, there's this MeshMixer software, and you can download that. Now, I'm just going to pop out and grab a mouse because unfortunately it doesn't work very well with the trackpad, so give me a sec. Yeah, so it's one of these pieces of software which has left click and right click and middle click and drag and left drag and right drag, and it's just so difficult to do with a trackpad. Okay, so let's actually jump back here and let's grab this one. So once you've uploaded it via the app or whatever, you can go on the website. You have to log in or sign up to use the app anyway, and then it puts it on your profile. So then we can go edit, download 3D models, and you'll see an STL file for 3D printing. But I might just grab the mesh package, and you can grab all the photos I used as well. So we'll download that.
So is this MeshMixer within 123?
So it's made by the same company, but it is a different piece of software. So I've installed it on the Mac. So this is MeshMixer here. We'll just wait for this to finish downloading.
Is it all free to use?
Yeah. I mean, I'm not 100% sure if there are like paid parts of it, but certainly everything we've seen so far is free. Okay, so we can import a model, and I'll just pop that on the desktop, mesh, and you'll see in here there's a 3DP file, but there's the OBJ file, which is the one which most things can open, so you can see it there. So if we open this, now they've changed MeshMixer recently, and now it is sort of tailored for 3D printing. So you can see the default environment I get is like supposed to be the MakerBot Replicator 2 format. So the first thing I want to do is, let's see if I can remember how to do this. It's align, and I want Z up, Z down. Can I do Z down? Flip. There we go. So I've just basically aligned it. So before it was sticking, like instead of it sitting vertical on the plate, it was sitting horizontal on the plate. So I've just changed the alignment so that now everything should be sitting on the build plate. So you can see, here's my camel in there, and we've got a bunch of, let me make this a little bit bigger. we've got a bunch of geometry, like so you can actually see the boxes which it's scanned around it, and then it's picked up a little bit of geometry in the background. So then what we might want to do is just select bits and pieces, and we can push X to delete them. So we can either, it's kind of interesting, so we've got our world origin floating down here. So I think the way it works is if you draw a line through the thing, everything on, I don't know, it must be everything on the smaller side of the line will basically get selected, so I can pretty easily sort of chop off geometry by that, or we can use the typical lasso stuff, so I can draw stuff around it. Or the other alternative is I can actually, if I move over, you see the little red dot with the grey thing, so that's basically like a paintbrush, so I can change the size of that and I can actually colour in parts of the model. So there's multiple ways to do bits and pieces with the geometry. So I can go through and basically cut off all this geometry to try and get just my 3D model of the camel. And I'm not going to spend too much time on this because I'm not actually going to 3D print it, but yeah, something I want to do. Anyway, you can see we've basically cut off, for the most part, or most of the geometry which we don't want. We've just got this camel and he's standing on like a little platform now. So yeah, and there's plenty of other features in here as well. So you can do sculpting and stuff if you want to tweak your model. You can do various stamps to do stuff, edit the model in mirrors, aligns, pivots, cuts, all that sort of stuff. So there's plenty of stuff in there you can do to modify your model, but I'm not a 3D graphics artist. This isn't a 3D graphics course. So if you want to get into 3D modeling, have a play around with it. Though, to be honest, I personally feel there are better tools for it. But this one just integrates well into the 123D Catch workflow. And if you just want to basically scan something, clean it up, 3D print it, it's perfectly adequate. So we talked about some other ones as well. So there was Trimensional, which is a 3D scanner for iPhone. But this, this was put in here before there was the 123D Catch app. So to be honest, it's probably just, you might as well just use 123D Catch these days. There are other things out there as well, though. And then sort of the last thing we talk about is laser scanning. And I mean, I mentioned before, when we talk about Connect, it's not really a laser scanner, but it's not really photogrammetry. I've thrown the slides in with laser scanning. Feel free to argue with me on the placement, whether it should be its own separate category or not, but it's right, you get the idea anyway. So, we've looked at making models by hand now, which is obviously allows you to get good results, but it's incredibly time consuming and requires a lot of expertise. Then there's photogrammetry, which is very easy, but sometimes the results aren't that flash. And then there's laser scanning, which is easy to use, automated, robust, industry precision, however, it's very costly. So, if you want to make perfect models, this might be and money is no object, it's perhaps not a bad thing. So there are things out there like the Polimas Fast Scan, which uses a magnetic tracker to determine the position of this device, and then it's got like a laser line painter and then 2 cameras which detect where the laser line is. And then there's software to fill in the geometry and basically end up with these near perfect models out the other end. There are things, however, out there. So there's Microsoft released their Connect Fusion software, a couple of years ago now, I suppose, which was sort of when it came out, blew everyone's mind. And it was kind of cool as well because up until that point, Microsoft had sort of taken you're not really supposed to be doing the stuff with the Kinect. It was supposed to be like an accessory for the Xbox, and all these people like, making software to run on, to do stuff which it wasn't meant to do. And Microsoft had originally, now it's loaded, had originally sort of been like, well, this isn't really what you're supposed to be doing with Connect. And then they sort of released this in 2011, which was sort of their unofficial endorsement to say, actually, you know what, it is what the stuff you guys is doing is pretty cool. So we're going to sort of officially support it. And then, of course, the Connect SDK came out, and that was them basically officially saying, yeah, okay, well, you guys can use the Connect. It doesn't have to just be for Xbox anymore. And then they released the Connect for Windows and all this other stuff as well. So the idea behind the Connect Fusion is it uses the Connect to basically reconstruct geometry using... So the way the Connect works is it has 3 cameras in it. I don't know if I actually have a picture in it. Well, sorry, two cameras. One which detects color, so the RGB, and the other one which they've got a laser diode in there, which basically projects a known pattern on the real world, and then they've got another one which picks up that infrared pattern and uses that to determine geometry. So from that you can get, if we just go back to here, yeah, so that's actually on top, that's actually in the software more so than on the Connect. So if we just go back to this one, you can see here, here's the depth map, basically visualized as grayscale data, but you get this RGB data, and then you get like the distance away each pixel is, and then from there you can reconstruct 3D models. You can track a user's skeleton and all that sort of stuff as well. So the Microsoft released the Connect Fusion, and it sort of blew everyone's mind, and then everyone sort of started sort of copying after it. So watch the Connect Fusion video when you got some time. It's pretty cool. It is kind of old now, but yeah, so it's available to use as part of the Connect for Windows SDK, and there's an open source version built into PCL, which is the Point Cloud library, so if you want to do that stuff. But the stuff they were doing with Connect Fusion was primarily sort of around imaging rooms and stuff like that, although you did see that one where they're imaging the guy. There are other things out there, so Skinect is the one we sort of mainly use in the lab, so talk to these guys if you want to know more about it. They've got it set up and running. But Skinect basically uses a structure sensor or a Connect or something, and allows you to make 3D scans and stuff. So, oftentimes being used to record 3D scans of people or whatever.
In that one, Adrian, what's the ideal colour that your model should be
I would say green. Yeah.
showing? Orange or yellow?
I mean, I'd say, yeah, like it'll be red to green. So orange and yellow is okay, but green is the best. Yeah. As far as how to get it green all the time, I guess it's just a matter of practicing these things and get it going. So here they are scanning a 3D model of someone, and then there's software in there to fix the geometry for filling holes and stuff like that as well. Which is pretty cool, and it's free for non-commercial uses, so we use it as sort of a demo because it kind of blows people's minds. There are other things as well, so there's Reconstruct Me, and Mathrix Labs has their own software as well. And then there's Matterport, which is used more for scanning spaces rather than objects. So just to sort of finish this up, here's a comparative analysis of some pieces of software, or you could sort of just really define these as being, the less so the software, but more the techniques. So you have Maya and ZBrush, which are basically 3D modeling pieces of software, so you do it all yourself. So it's not fast, they're not easy. They're accurate and, they're robust, but their accuracy completely depends on how much time you want to spend and how skilled you are. Low cost, not really, and definitely not for unskilled users. Then there's 123D Catch, so photogrammetry. It's fast. It's pretty fast. Definitely faster than this. Easy to use, it's easy to use, take photos. Accurate, robust. The quality you get often, the quality you get often isn't that great, as we saw in some of the examples. It is free to use essentially, and easily to use by an unskilled user. The laser scanners, they're fast, they're easy to use, they're very accurate and robust, but they're ridiculously expensive. Whereas, the Skinect or the Connect-based scanning thing's fast, easy to use. Generally pretty accurate. If you're watching the Connect Fusion demo, they actually scan like around a desktop, and they're scanning a Dell monitor, and it actually detects the Dell logo on it, which I think is only like 1 millimeter or 1.5 millimeter depth. So it has the potential to actually be pretty good. And Skinect free for non-commercial uses, and unskilled. If you sit down and spend sort of 15 minutes with it, you should be good to go, hopefully. So that is atoms to bits. Any questions, comments, queries?
When you 3D printing it, is normally printed one color.
Yeah, so we're just about to get into bits to atoms. Yeah, that's all right. That's a nice little segue. So yeah, that's obviously going from atoms to bits. So we've got real world things, and we want to digitize them, so we can do so by those sort of various methods. The other way is, going from bits to atoms. So starting off with these digital abstract concepts and making real world things out of them. And obviously the most famous example is like on Star Trek. They had, the holodeck or the materializers and stuff, which they could ask for stuff, and it would basically combine atoms to make whatever they asked for. We're still a long way away from that, but I guess 3D printing is sort of where we're starting anyway. as far as physical objects, you could argue that augmented reality sort of handles the holodeck side of things, and that's what Microsoft's trying to pitch with their HoloLens. But
Can you just mention 3D printing? What is at the forefront of that now? What are they printing? State of the art.
if you can hold on for another 10 minutes, we'll get there. Yeah. So we're going to start with the history, but we will go through to sort of
I'm sorry, you said something on Microsoft HoloLens.
Microsoft HoloLens. So it's a new augmented reality display that Microsoft's building, they're basically making huge investments in it. They're saying that it's basically the whole thing is Microsoft is going for 3 markets now. They're going for the mobile computing, so desktop, tablets, mobile phones, stuff like that with the Windows 10 stuff. Then they're doing desktop with Windows 10, and then they're doing HoloLens as sort of their third main computing platform going forward. So they're making huge. It's kind of funny considering the HIT Lab is sort of for the past 15 years, whatever, and then the HIT Lab US for another 10 years before that has been like focusing on AR technology and trying to sell people that it's good. And in the last year, everyone's like, oh yeah, AR technology. It's like, finally. Anyway, so yeah, 3D printers. Everyone obviously is going on about how 3D printers are the latest, greatest thing. They're not. They've been around since the 80s. It's just they used to be ridiculously expensive and bulky, and nobody really saw the need or the use for them. So there's a few different types of 3D printers that we'll look at, or rather how they work. So stereolithography, which we'll look these 3 things anyway we'll look at. So stereolithography has been around arguably since 1984 from 3D Systems. Fused deposition modeling, which is the 3D printers that we have, in 1988. 3D digital printing from Z Corp by 1993. So, none of this is new. It's been around forever. It's just now it's affordable for people to actually use rather than just crazy rich companies. So I said we're going to talk about the various things. So 3D printing, what most people think of as 3D printing is fused deposition modeling. So fused deposition modeling, it's the idea of making a coil pot. So I don't know if you guys ever did anything, but coil pots are like when you're a kid or whatever in your art classes, you get clay and you coil it round and round and round, and you basically build up a pot like that. That's how fused deposition modeling works. The idea is you melt a plastic material and then you squirt it through a nozzle and you just layer it on top of each other over and over again. That's what most people think about. Really, 3D printing is probably more what, you can break down these things into various things, but what 3D printing is probably more accurately described as is additive fabrication. So the idea behind additive fabrication is that you start with nothing and then you add stuff to it to make something. The other end of it, of course, is subtractive fabricating, where you start with something like a block of wood and then you carve out the shape from it. So that's milling and stuff like that. So there are machines which work in much the same way 3D printers work, but instead of having a nozzle which squirts out ink, they have a spinning drill bit, and then they cut out shapes from stuff, and that's called milling. And it's subtractive fabrication. Most people don't call that 3D printing, so yeah. 3D printing, and now I got these definitions off this website, and there is a lot of sort of argument about what these various terms are, but I think these guys did a pretty good job sort of defining it. So this is how they define additive fabrication. They define 3D printing as an object made using inkjet technology in 3D, which is basically not what any 3D printers do, really. So that would be, you stick a cartridge into a 3D printer and then it sort of prints up. I mean, the difference between that and fused deposition modeling is kind of hard to define anyway. But certainly these 3 down the bottom here. So fused deposition modeling, stereolithography, and selective laser sintering. These are the 3 that you're likely to see. This is the definition that I give when I'm describing what 3D printing is, because, this basically includes all of these really, but these are the 3 ones that if you go out and buy a 3D printer, it will most likely do one of these 3 things. So we'll talk about them in a little bit more detail now. So 3D printing refers to an object made of inkjet technology in 3 dimensions by laying powder and binding with pigmented glue. So that's what these guys have defined 3D printing as. So you basically print powder and then glue it together rather than squirting out plastic or whatever, which the difference of it is semantics more than anything really, but the fused deposition, I would agree that fused deposition modeling is a good description for what our 3D printers do. So we have MakerBots, which are FDM 3D printers, and basically they heat a material, typically plastic, ABS or PLA plastic, and they heat it up to like 140 degrees to what point it melts, and then they push it through an extruder, and it gives it a very fine, like a hot glue gun basically, and it just does layer upon layer upon layer of that. And this is what probably, I mean, I don't know the numbers, but I'd say there's probably like 80% of 3D printers you can buy out there now use FDM because it's one of the most simple and reliable ways and cheap ways of 3D printing or additive manufacturing. So fused deposition modeling basically is built on top of CNC, which is computer numerical control, which is a 3-axis print head, essentially. So it can move in 3 dimensions, so that way, and that way. And typically it's done by just putting it on a gantry. So if you look at our 3D printer, it's got a pole which runs from side to side, which allows it to move that way. It's got 2 poles which run that way, which allow it to move back and forward, and then it's got a couple up which allow it to move up and down. There are different types of 3D printers as well. So there are ones which are, well, a few FDM machines which are known as Delta bots, which instead of having like a box with 3 like rods which go in different dimensions, they're more like it's hard to sort of describe. You basically have 3 pillars, and each one of them is connected via like a flexible arm. So the idea is you have the print head is floating there, and it's got 3 things connecting it, and as you pull one of them, it will shift that direction, pull the other one will shift that. And so the idea is if you pull all 3, it'll move directly up. If you loosen all 3, they'll move down. And then if you like pull and release other ones, you can move it in all 3 dimensions. Actually, it's probably just easier to try and show you rather than describe what they look like. YouTube Delta bot, Delta 3D printer. So this is one here essentially. Let's see if we can get some footage of it actually. This one might be better. So they got arms which basically, you raise or lift and lower the arms in certain configurations, and it will move the head round. The main advantage to doing this is it generally is slightly smaller than one with 3 big boxes, because you can the length of these basically define the size of the build space, and it's fewer moving parts as well. So you have essentially these 3 things, and they control it in 3 dimensions rather than having rails and bearings running in 3 dimensions. But they are a little bit harder to sort of control, obviously, because in a traditional 3D printer, if you want to print to the left, you just pull on one or turn one motor, whereas this one, the maths is a little bit more complicated to make sure it goes. These ones potentially have a little bit. I have seen ones of these which actually allow the print head to not just move but rotate, which is kind of cool as well, because then you can print quite complex shapes where instead of just going like that, you can actually start printing if you wanted to build, and we'll have a look at this in a moment. So this is the robot that I scanned, and you can see here he's got one of his arms up in the air. So in order to print that with the one we have to print these massive scaffoldings so that when we print it, it has something to sit on. But if you can rotate the print head, you can actually print this and then rotate and start printing out that way, rather than having to always print relative to gravity. You can start printing off to the side. So there is a bit more there. I have seen 1 or 2 which do it, but they don't tend to do it very well, like ones which people have built. So I think that is possibly a technology to keep an eye out for, like 3D printers which will be able to actually rotate and print round rather than just moving. So CNC, which will basically control it, and then you have the extruder, which has effectively 3 parts. It's got a feeder. So in our one, there's a couple of like little cogs which you feed the filament into, and then they just rotate round and pull the filament into it. The heated barrel, so then it pushes the thing or the filament into this barrel, which is usually between 130 to 140 degrees Celsius, melts it, and then you've got the nozzle, which is obviously just a little nozzle with a very fine tip. So as it keeps pushing on it, it will print it out a nice thin line. And that's basically what you've got there. So you've got the drive wheels of the feeder, and then you've got the liquefier, which melts it all, and then you've got the tip, which squirts it out, and then it just goes back and forth and layers it up like that clay pot. The process which effectively happens, you start with your 3D model, it converts that to G code, which then is processed by the 3D printer, and it basically tells it where to move and all the instructions, like heat the head to this speed, move to 0, 0, 0, and then all the instructions for moving it around, and then it 3D prints and you've got your final object. So that's probably the most common fused deposition modeling. There are some other technologies as well. So stereolithography uses a laser, typically UV light or laser, which uses mirrors to scan it over a pool of photosensitive liquid. So you have this liquid, and when a concentrated UV light shines on it, it hardens. So you have a laser, and it basically bounces off some mirrors, and you can shine it into the liquid, and it hardens up. And then typically you have some sort of platform, so you're only ever shining it on like a little bit, and then you move the platform down into the resin as you go. So a while ago there was this company which did a Kickstarter and raised just ridiculous amounts of money, and they were doing Peachy printer, which was supposed to be the first $100 3D printer. And it actually works with stereolithography, and it was quite a clever idea actually. So the idea is, there's obviously a lot of expensive bits and pieces which go into a FDM printer. You've got motors and rails and bearings and all these bits and pieces, which, while none of them are super duper expensive, when you add them all up, it gets quite costly. So what this guy did instead was he came up with the idea of using a laser and photosensitive material, and then he's got these two or three tiny little mirrors which basically move the mirrors move, and the laser bounces off them, and that allows them to control where on the thing it's shining. But the mirrors are actually controlled by the sound card of your computer. So you plug it into the sound card, and then that's used with a tiny little magnet, which I guess you can see here, which basically moves because speakers are essentially just magnets which move a membrane which pushes air, and then the airwaves go into your ears. Essentially all he did was remove the membrane and put a magnet on the back of a mirror, so that when it's the coil is becoming magnetized, it's just pulling the mirror a little bit, and then it just shines it onto the liquid. And then he just had this little thing which it was actually quite clever as well. So a little aquarium pump sort of thing. I don't know if they've changed it now, perhaps they have, but the original prototype had an aquarium pump which just dripped the liquid at a constant rate. So rather than needing a platform which moved down like in this one here, essentially the liquid just fills up at a constant rate. So every time you're writing or lasering into it, basically you laser into it, and it fills up at a constant rate, so you're always lasering on the very top. And since they're doing their Kickstarter, I don't know, the Kickstarter was probably at least a couple of years ago now, and they still seem to be sort of slowly ticking along. It's taken them a long time, but these are some of the things which have been printed on it. So they're little promotional videos. So this is the laser basically shining on the liquid. Oh, that's snap fit assembly. Attention, not all assembly steps are snap fit, so it's kind of easy, but not that easy. Yeah. Yeah, I mean, that's the thing. For $100, you can't complain too much. Yeah, so pretty cool. And one of the cool things about stereolithography over fused deposition modeling is because it sits in its own medium, you can do like hollow structures and stuff like that. So again, looking at these examples, you see that all the scaffolding which needs to be printed, because this is just floating in, or like on this one it floats in suspension, there's no scaffolding needed. As it prints, it just glues it to the nearest part, or like it just solidifies to the nearest part. So you could theoretically, rather than printing this and then having to spend all the time removing it, you just print something straight out like that. And the resolution of it being that it's a laser rather than a little nozzle is potentially pretty incredible. Like in this case, the hardest part about the resolution, or the thing which limits the resolution, is how accurately you can move the mirrors and stuff like that. But effectively, you're dealing with laser light, so it can be pretty, if it's focused correctly and the mirror's moving, it can be pretty accurate. So quite cool. And then the last one is selective laser sintering, which is basically the same as stereolithography, except instead of using liquid, you use powder. And then you shoot a strong enough laser at it, and it causes the powder to change. So the cool thing about selective laser sintering is you can do stuff like metals and stuff like that, which they're starting to be able to do in like fused deposition modeling, but it requires like obviously pretty crazy amounts of, to heat a metal is quite hard if you're just using like a heated filament thing, whereas with laser sintering, I mean, you just shoot a strong enough laser at anything and it will melt eventually. So, but this one has all the advantages again of the stereolithography, and even more so because you've got this powder which you're converting, like the powder acts as its own scaffolding. So when you're done, you just reach in and pull your part out, and it's ready to go. Like, you don't have to worry about pulling off any bits and pieces. There is another thing in here which I don't mention before, but it's sort of a weird thing which sort of sits between additive and subtractive, which is like laminated object manufacturing, where essentially you take multiple layers of stuff and you glue them together and then you cut them out. So whether it is kind of halfway between additive and subtractive, because you're adding layers, but then you're actually cutting away from the layers. So I don't know, take your pick which camp, whether you call that additive or subtractive. But there is a company which does this stuff, and I've actually been able to see these guys. I was at CES at the start of this year, the huge big tech show in Vegas, and these guys were there with one of their 3D printers showing off their stuff. And effectively what this does is it is a printer, binder, or color printer, binder, and cutter all in one. So you stick in like a big fat wad of A4 paper, it runs it through a standard color inkjet printer, and then it glues the paper together, and then it cuts around the paper. And so these are the 3D prints that they're coming up with, and you can see they're pretty high resolution. And one thing these have over pretty much all the other techniques is you can print in full color, because it's effectively just a color printer. Fused deposition modeling, you can print in color, obviously, if you have multiple filaments going into it. So there are various 3D printers which will have 2 or 3 filaments, which allows you to print in one color and then print in another color. And you could arguably mix the colors a little bit to sort of get somewhere in between them, but it's not that easy. On the peachy one, they're talking about how there's 8 different colors, but the color you get is the color of the liquid you put in there. So it's not like halfway through a print, you can be like, oh, I want the other half to be this color. And selective laser sintering is kind of the same. Whereas with this, because effectively, like all this is thousands of, thousands of pieces of paper which have been printed in color, glued together and then cut out. You have anything you can print in color on a normal printer, you can get that color. So, and these are actually surprisingly solid. So I got to pick up and hold some of them, and I mean, it feels like wood essentially, because effectively paper is just wood. So they have the consistency of something like, I guess, balsa wood or one of those lightweight woods. But they're robust enough. Like if you 3D printed a hammer, you might be able to hammer in one nail before it breaks to pieces. But they're good enough. And yeah, it was really cool to sort of see the resolution of them and the color and the quality. because obviously the layer resolutions, that's one thing. In the models you 3D print now, is you can look at them, and I'll hand these around soon, and you can see each individual layer, like each time the head's gone around. With this, the layer is literally the thickness of a piece of paper, because that's exactly what the layer is. It's just a piece of paper which has been glued to the next piece of paper down. But yeah, an all-in-one machine, which you basically stick a ream of paper or several reams of paper on one side and you get your 3D model. And it's actually another thing, I know I'm seeing their virtues, I just thought it was really cool when I saw it, but another thing, like the way it cuts around it, it's sort of like a perforated cut. So when you actually get your object out, it's still on a solid block of paper, and then you just sort of like pull the paper away from the edges. But that makes it great for packaging. You know, if you run a company which prints these things, you basically stick your A4 paper in, you print your 3D model out, and you just get like a big ream of paper that you stick in a box and mail off to your customer, and when it gets there, they just like grab the paper and just pull it, and then the 3D model falls out. So it was pretty cool, and yeah.
They're very light as well.
What's that, sorry?
What would be the approximate cost?
I think the printers are quite expensive, like they're probably in the tens of thousands. But I mean, I asked them about how much it costs to actually print, and they reckon that, you know, like a model, they had one, which was probably roughly about hand size, and I think they said it was about $5 or $6 worth of material. So it actually wasn't as bad as I thought, like, because it's with the ink as well, like they only print the very outside of the paper. It's not like it's printing the whole way through. So if you know, you cut the skull or the guy's head in half, it will be white on the inside, which kind of makes sense. You're not wasting ink printing stuff you're never going to see. So really, I mean, paper's not that expensive. So, and I guess the other thing as well is like it's not toxic. So they could get around a whole bunch of things, you know, printing. Like if particularly in the States and stuff like that, if you're producing toys or whatever, they have to be, you know, for children, they have to be made of certain safe materials in case the child eats it. I mean, paper's pretty safe. You know, you can eat it, and unless you eat a ton of it, you're probably not going to die. You might make yourself sick, but you know, whereas if you eat one of these, some of the plastics can leach out and stuff. So, yeah, it was just really cool, like seeing it working and talking to the people. They were really enthusiastic about the company. So. Anyway, so that's sort of the I guess the definition. So we'll just go through a little bit of the history and then finish up with some applications and future directions of 3D print. Oh, and some obviously examples of how to use it as well. So commercial 3D printing in recent years, rapid prototyping machines have become more compact and available at semi-affordable price points. So you know that you can buy these 3D printers from commercial places. Even, you know, a while ago, there's things like the Grizzly CNC and you'd mentioned print, and these are like sort of real, like commercial offerings by companies. But, you know, they're still in the tens of thousands of dollars, which put them out of reach for most, apart from the very wealthy, like most people. However, you know, there's been, in the last decade, really, there's been this huge push towards sort of tinkering, hacking, DIY, all that sort of stuff. So, you know, it sort of started with all the open source software movement. So people like, let's make software which anyone can modify and tweak and do whatever with. And then as we talked about with the Arduino like things, that sort of inspired some of these electronics people. And they're like, we should make open source electronics platforms that people can, you know, you can buy an Arduino and then you can tweak it, hack it, whatever you want. And then, of course, you know, then you've got the software, you've got the electronics. It's like, well, all we're really missing is, you know, basically going down to Bunnings Warehouse or Mitre 10 and buying some bits and pieces and, you know, recreating one of these tens of thousands of dollars machines ourselves. And that's exactly what people did. So this is actually a milling machine, not a 3D printing machine. So you can actually see there's a drill. And this is actually just a drill, like, that you'd go and buy from one of these stores, and somebody's just basically taken some wood and some rails and motors and connected it up with probably an Arduino or something, and it just pushes the button on the drill, and then it goes around and drills out stuff out of foam or wood or whatever. So yeah, people started making their own things, and then obviously, you know, you make one, and then other people are like, oh, that's really cool. So they put their plans online for how to build them, and for some of them, you could basically, you know, if this one can mill wood, theoretically, it could mill all its own parts. So you build a 3D printer and then you mill some parts and you give them to your friend, and then when they build their one, they mill some parts and give it to the next friend. So everyone sort of helps out the next person in the chain, or you can obviously just go online and buy the parts from a company. And that's pretty much exactly what happened in 3D printing. So there was this company, RepRap, who I'm sure they weren't the first, but they were still one of the first. But they basically, the idea behind RepRap is it stands for Replicating Rapid Prototyper. So it is a 3D printer, and all the parts which you can't just go down and buy from a hardware store are printed on RepRap. So you meet someone, you go to a fab lab or someone, and you print out all the parts, and then you build your own 3D printer, and then you print out some parts, and you give them to the next person in the chain, and everyone helps everyone else, and everybody wins. So this is the RepRap here. This is obviously a pretty sort of jerry-rigged sort of contraption, but it works. It 3D prints. You've got your base there, and then you've got, so your head actually only moves in two dimensions, and then your base moves up and down to allow you to print on it rather than our one does as well. The base moves up and down, and the printing head stays where it all moves in 2 dimensions, and then the base drops down as it goes. And all the connecting components, all these white bits and pieces you can see here are printed out on a RepRap. And there's basically another RepRap. This is the Mendel, and this is just hardware you can buy, or you can build your own to control it as well. So it's not Arduino, but it'll be something similar, maybe a BeagleBone or something to control it. But you can build them with out of Arduino as well. There's plenty of software out there to do it. So RepRap was great. However, you still have to be at least a little bit sort of switched on in order to do it. So Bree Pettis, who was the MakerBot co-founder, basically said it's still not trivial to put a RepRap together. It requires a lot of enthusiasm, a healthy dose of bravery, and the ability to navigate a project that is growing and changing every day. There aren't step-by-step instructions, which makes it a very, very challenging project. So one of our PhD students from a few years back actually built his own RepRap, and he was lucky to get 2 or 3 prints out of it before something would need adjusting, something would break. You go online, you search RepRap instructions, and you get 100,000 hits from people who are trying and doing various things. And because it is, a build it yourself, like everyone builds it slightly differently, everyone's got their own advice, everyone changes it slightly. So you need to sort of go, if you want to build a RepRap, you need to spend like a month reading everything to sort of absorb it all and say, okay, now that I've read all this, this is how I'm going to build my printer. It's not just a simple, you could go on there and, just take one person's advice, but you're probably not going to end up with the best device that you can get. So MakerBot came along and they said, okay, well, let's just sell kits. Essentially, you can go on our website and you can buy a kit like this, and then it just comes flat packed, IKEA style, and you assemble it yourself. And obviously, our 3D printers by MakerBot, they don't look like this anymore. But if you actually look at them, they're still made of thin plywood, which has just been painted to make it look slightly nicer, and the control electronics are sort of hidden inside the box and stuff. So it's obviously a bit flashier now than it used to be, but this is where they started. This is the MakerBot Cupcake, which was called that because it could print roughly the size of a cupcake. And you could download all the CAD files and stuff yourself as well to if you wanted to make it, and then you just buy the extruder off them, or buy the bits and pieces and build the extruder yourself if you wanted, and then get the electronics and hook it all up. And then there's other accessories as well, so you get spools for the filament which sit in the back and hang it all around. And it worked, here's the MakerBot Cupcake for the cupcake printer and printing someone's head. You can see very obviously the layers of the resolution stuff. And since then, MakerBot's sort of gone a little bit fancier and a little bit more high tech, and this is sort of their range of offerings that I pulled off their website yesterday. So there's the MakerBot Mini, which I guess is sort of what the cupcake became. And then there's the Replicator and the Replicator 2X and the Replicator Z18, which is like much fancier and bigger and stuff. So that's MakerBot. They're obviously not the only people out there, but they've sort of made a name for themselves. Our 3D printers are MakerBot replicators. So, they've done well in that they've partnered with things. So our MakerBots are serviced by Ricoh, who do, our huge big office printer and stuff as well. So they've managed to partner with a bunch of companies so that they sort of do what they do. And then other companies, when our 3D printers break, Ricoh comes and takes them away, and then they repair them and bring them back to us, which is great because you can repair these yourself, but if you can get someone professional to do it, obviously, well, for one, it doesn't take up all of our time doing it, and two, they can get the professional parts. You can, the early 3D prints were all about if something, you print you get your 3D printer and the first thing you do is you print out all the parts for your 3D printer, so if anything breaks, you've got a replacement you can just replace. However, obviously it's not as strong as something which has been like cast in, injection molded and all that sort of stuff. So it's sort of, I don't know maybe how the MakerBot guys would feel when they started, if they looked at what their products were now, whether they feel they've sort of lost their way, their mission of creating these sort of homemade things and now they're like really fancy and official and stuff, or whether they'll be like, yeah, this is sort of where we saw ourselves ending up. I don't know. You can argue it two ways. But the fact of the matter is MakerBot aren't the only ones out there. If you still want to, get a kit set 3D printer, there's still lots of people who do it. So just to look at a couple of these, so there's the Fab at Home ones as well. So Fab at Home is kind of interesting because instead of using filaments that they melt, they use syringes. And anything which is liquid enough, which will harden when you heat it up, you can put in a syringe. So you can print in silicon, cement, stainless steel. If you can heat it up, well, you replace the silicon things obviously with something which can, or the plastic syringes with obviously something that can handle stainless steel, but you can print in cake frosting, cheese, so you can, make edible 3D printing stuff, which is kind of cool. And, you can swap out, because it's just essentially a solenoid which is pushing down on this, you can pretty easily put multiple ones in there, so you could print in frosting and cheese at the same time if you really wanted. I'm not quite sure how that would taste. But anyway, so Fab at Home have their own 3D printers. There's Candy Fab by Evil Mad Scientist Laboratories, which prints in sugar. Sugar being that when you heat it, it caramelizes and sticks together. So you can make arbitrary 3D objects from a variety of low-point melting materials, including pure sugar. So, here's a massive sugar helix, here's a massive sugar screw and nut. Obviously, it's, not, they look a bit rough, but that's what you get when you print in sugar, really. And as far as, so what you're asking about is where's the future directions. So I put this slide together last year, but I think, to be honest, it's probably still fairly relevant. So obviously there's the quality. So this is 2006 to 2008, and it's only would have gotten better, but to be honest, the improvements are probably not as noticeable. So if you look at this is pretty rough quality, and this hole is being drilled out by someone. It's not actually 3D printed. Then, you've got this one, which is slightly higher resolution, and this one, which is actually quite good. So these are prints off one of our 3D printers, and you have a look at them, you can still see seams and stuff like that, but it will get better. There are other ways of doing it as well. So some people talk about, with those ones, you treat them afterwards with an acetone bath, which actually sort of melts the plastic a little bit, so it smooths off some of the edges. So there's lots of ways that the quality could improve, and obviously, that also comes down to the size of the nozzle and what technologies you're using. So you're using selective laser sintering or fused deposition modeling, whatever. But the quality is only going to get better.
Seeing that there, did you sit and just
I did. And that's exactly what you guys will have to do when you 3D print your own heads. Then obviously there's price. So Peachy Printer came out, $100 3D printer. So this is actually what it looked like on their Kickstarter. So it's changed a little bit since then. But yeah, they'll get cheaper and cheaper. The MakerBot ones are still in the, probably $2,000 to $5,000 range. So they're not super duper cheap, but they're also not in the $25,000 to $30,000 range. So they are cheaper. Peachy Printer goes down in cost again. Materials is obviously a big one. 3D printing metal at room temperature is something which is sort of one of the holy grails. There are companies which can do it, like if you search online, there are metal 3D printers, and there's an example of one thing where they 3D print out a spanner, which then the guy pulls out of the thing. I think that might be using selective laser sintering rather than fused deposition modeling, but he pulls a spanner out and then he tightens the nut on a car, which is pretty cool. Being able to do FDM, FDM is probably where most things are going to go, to be honest. It's kind of the way everyone seems to be working, apart from Peachy. But being able to 3D print metal at room temperature is pretty good, because obviously metal is incredibly strong. Some of the other things as well, carbon fibre is a big one, which everyone's looking at doing. The challenge, obviously, with carbon fibre is that it gets its strength from its structure. So you need to sort of print down a layer and then print the carbon fibre as a weave within it. But there are people who are working at that. I remember the first probably about 2 years ago, they're like, the first carbon fibre 3D printer, but they sort of missed the point because they weren't actually weaving the carbon fibre in it. I think they were just like chopping up carbon fibre and melting it. And it's like, well, that's carbon fibre gets its strength from the fact that you weave it through so it holds its shape. Colour. So obviously the M-Core one prints in colour because it uses paper. Prodesk 3D, I'm pretty sure, uses more of a plastic powdery stuff, but it actually dyes the powder as it's coming through. So it has a powder which it heats up and melts, but as the powder's going through, it's using inkjet technology basically to dye it. So there's a little vase of flowers that they dyed. Content creation, so MakerBot also, in addition to all their 3D printers, they also have the MakerBot Digitizer, which is a 3D scanner, and it's basically plugged directly into your MakerBot, and it's got a little turnstile and a laser scanner, and you push a button and it rotates your thing around, scans it, makes a 3D model and starts printing. So instead of this whole thing of I'm going to scan, make a 3D model, whatever, then I'm going to take it to your thing, this is a photocopier for 3D printing essentially. You plug it in, you put your object on, push one button, and it will go through the whole process of creating a 3D model and printing it out in theoretically one button push, which is essentially what a photocopier does, which is kind of neat. And then scale. I mean, scale and quality are pretty intrinsically linked. But, you know, they're talking about what can be done with 3D printing in a bunch of different fields, like obviously there's all the manufacturing, but there's also medical and all that sort of stuff. And one of the things which sort of will enable that is scale. So here is a race car which was 3D printed, and that's 285 micrometers, which is what's a micrometer like? I think a micrometer is 1,000th of a millimeter or something. So this is basically being imaged with a scanning electron microscope. That's how small it is. I think that might be a human hair actually in the background. So it's tiny. Yeah. Anyway, so let's have a look at some. Actually, we'll take just a short break there because we're pretty much on to the last straight. So bathroom, coffee, whatever. We'll have a quick 5-minute break and then we'll come back and we'll look at how we can, or how we 3D print, and then we'll just go through some applications and we're done. Awesome.